Congrats, you made it this far. We created the window and then we created the shader files and created a texture, and we're rendering this texture every frame. Hey, welcome back to the ByteForce 1 C++ tutorial series. This is the second video of the series. We will be getting our development environment all set up, and we'll get our first window displayed with our BF1 ByteForce 1 ship. As you can see, I'm on a Windows system, so I will be walking through how to set up this game on a Windows system. If you're on another operating system, it'll be similar. It'll be the same steps, but might look a little bit different. If you run into any issues, downloading the dependencies or installing anything, just comment below and I'll try to help you out. To begin, the first thing you'll need is, well, obviously since this is in C++, we'll need a C++ compiler. So just make sure that you have any compiler. I'm using the G++ compiler. So yeah, just make sure you have something that can compile your C++ code. Once you have your compiler ready, we need to install the GLFW library. GLFW is the graphics library framework that we use for OpenGL. This is what we use to create the windows, manage input, from the keyboard or mouse. So really important. I'll go ahead and come over here and go to the pre-compiled binaries. Since I'm on Windows, I'll get the Windows binaries. So then you'll extract. And this is what we have. So it gave us the include files that we need, the header files. We're also going to need the library files. So this is for the MinGW W64. So first you need to find out where your compiler's include path is. So to find your path, the include path on Windows, this is what I used. So you're just trying to find, the string that says include search starts here. So here we can see this is where the compiler is looking for the include files or all the header files there. All right, so I'll go ahead and move the include files, move that into here. And then I need to move, the library files. So we go here and I hope. Now before we move on, I just want to test that this worked as it should. We'll go ahead and make the directory. So make dir ByteForce 1. And then we'll open this up in Visual Studio Code. We'll create a simple main.c++ file. And what we'll do here is we're going to double check that GLFW was installed correctly. So it compiles and it runs. That means that this is working correctly. If it isn't set up correctly, you'll see something like this when you try to compile. It'll say, yeah, no such file directory. It can't find that. So the next thing we need is GLAD, another library. It's called GLAD. From my understanding, GLAD is a tool that simplifies the process of using OpenGL functions. If you weren't to use GLAD, you'd have to tell the compiler where every OpenGL function that you use is located on your machine. So GLAD helps us. It actually looks up and finds where the OpenGL functions are at compile time, so that we, as the developer, we don't have to specify that. That's how I understand it. I could be understanding it a little bit wrong. If I am, please comment below. You want to make sure you have the C++ language selected. You want to make sure that the specification is OpenGL. We actually want the core profile. Then API, we want 3.3 or later. And then we want to generate a loader. And I believe that's it. Oh, this switched to compatible. So make sure profile is core, and we'll generate. And then you'll download. Go ahead and download the zip file, and we'll open that up. Extract. Okay, so here we get the include and source. So the include folder has the header files again, and then the source has our source C file. You want to go to your compiler's include path and go ahead and move these folders from what you downloaded into the include. It looks like I already have this KHR platform. I'm gonna go ahead and overwrite it. Okay. And then the source, we actually want to put the source file, so our C file, we want to move that into our project directory. All right, let's test this out and let's run include. Make sure, okay, looks like it's recognizing GLAD, so that's good. Go ahead and compile. Oh yeah, and one thing is you have to include GLAD before the GL framework. I can't remember why, but okay. And that is all the dependencies that we need right now. So again, we installed the GLFW library, and then we also installed the GLAD library. If you had any issues installing or moving these files, or you have any more questions, just comment below. I'll make sure to answer them. But okay, we're ready to start writing code. We're ready to create our first window and get that up and running. Okay, first I would just want to define our screen width and height, because we'll need that later. Now we want to initialize our graphics library framework. And then we want to give our graphics library framework a few hints. So we want to tell it the version that we're using. Next thing, and this is only for Apple, but I'll go ahead and put it in here. If you're using a Mac, you have to add this. At least this was my experience. Maybe you'll have better luck. This is just saying that we are forward compatible, and it's something that I needed to add when I was using a Mac. Then we just want to make sure that we make the window resizable. Now that we have all these hints and we initialized GLFW, we can go ahead and create our window. Okay, now that we created the window, now we tell OpenGL, okay, let's use this window and put it into our current context. Okay, now we need to do some GLAD configuration. So we'll just make sure that GLAD loads correctly. Now I'm going to see if this compiles. Just want to double check. And when we compile, we also want to include the GLAD C file. Okay, I'm getting this error when I'm trying to compile. Okay, so what I needed to do was just add the GDI32. If you're on Windows, make sure you link the GDI32. And then if we run it, you'll see the window popped up. But it goes away really fast because we create the window, we make it the current context, and then it goes away. So we need to make sure to keep the window open until we exit out. So now we're going to do some OpenGL configuration. If you want to know more about, these OpenGL functions, and how they work, I would definitely suggest going to the Learn OpenGL site. And here, you can find everything that we've done so far, and see, what's happening. What does each function do? Or you can look at the OpenGL documentation itself. Now we'll make sure that the window stays open and doesn't close immediately once the program is run. So on every iteration, we want to clear the color and kind of restart the render. Then we want to swap buffers. Let's see what that does. Okay, you can see we have our window now, ByteForce 1, and it stays open. Be extra cautious. We will go ahead and call the terminate function. So before we're done with the initial window setup, we'll go ahead and add a couple more things. So up here, we're going to declare a new function, call it, following Learn OpenGL site, we'll keep the same name, frame buffer size callback. And then we're also going to add a key callback function. We'll go ahead and implement those functions down below. So let's go ahead and compile and run just to make sure we don't have any errors or anything. Okay, so here's our window again. Let's try to hit escape. On escape, it closes. And then we can resize. All right, now that we have our window appearing, next we're gonna actually try to display a ship, ByteForce 1, the main ship, the good guy ship. So I'm going to walk through the whole process of getting that working with OpenGL. I will warn, it's a little bit of a process, so just be patient. We're going to get it to render. So let's go ahead and get started with that. So in order to display different objects in OpenGL, we're actually going to need something called shaders. And as you can see on the Learn OpenGL site, shaders are little programs that rest on the GPU. These programs are run for specific section for the graphics pipeline. So we're going to need two different shaders. We're going to need a vertex shader and a fragment shader. Vertex shader is all about the position and shape of the object, where fragment shader is all about the color and appearance of the object's pixels. So, and if you want more, if you want to dig into this a little bit more, I highly suggest going through this section in learnopengl.com. It goes through the shaders, so vertex and fragment shaders. So let's go ahead and create our files here. So they're separate files. So we have our sprite.fragment and sprite.vertex. All right, first we'll start with the fragment shader. Then we'll write the vertex shader. Okay, now that we have our shaders ready, let's go back to the main file and let's load our shaders. Make sure to include the fstream header file. And we're also going to include the SS stream. Now we'll compile the shaders. Finally, we'll link the shaders and use them. Next, we need to define our projection matrix. And in order to use GLM mat4, we need to import the GLM header file as well. So GLM is graphics library math. Go ahead and grab that. Okay, then just copy or move the GLM folder into your compiler include path. And then to get the ortho method, we need to include the matrix transform header. I don't know why VS Code is marking this as an error because we are including these files. As you can see, I can compile and everything works. And now to get the value pointer method, come back and we need to include that from GLM as well. Okay, at this point we are done with the shaders, so we will delete them. Alright, now we need to create something that's called a vertex array object and vertex buffer object. And I'm not going to go too much into detail into this because Once again, Learn OpenGL has a lot more information about this. So if you come to the Learn OpenGL site and then go to the Hello Triangle section, the more detail about the vertex buffer array and then the vertex array object. Okay, now that all that is set up, now we need to work with our textures. And again, I suggest that you look at OpenGL, Learn OpenGL sites for this. They have a textures section, so it just gives you more of a background on what we're doing. All right, this is what we're using: Space Shooter Redux. So you just Google that, and we get all these assets here. And for now, we're just going to grab one ship to bring over. We'll bring over the rest of the files later. But if we just come down here, copy that into here, and then load that in. All right, now that we loaded and created our texture, we'll go ahead and render our texture. All right, and here we're just doing our translations and rotations and scaling. All right, let's see if this compiles. Nope. All right, just mixed up some of the parentheses here. With STB image, one of the first lines is do this. So we add this line before you include this file. Go ahead and copy that and then paste that just before we include STB. All right, so we got it to compile. Let's see if anything shows up. Hey, there we are. So this is our ship. So congrats, you made it this far. We have our window. We created the window, and then we created the shader files and created a texture, and we're rendering this texture every frame. Let's go ahead and try to add one more thing. Let's try to add some movement. Let's try to move our ship left and right. Okay, now let's go ahead and add the player position as a variable, so that way we can better keep track of the player's position. I'll just go ahead and create that right before the main while loop that we have. And obviously this will be updated. At the end of this video, we're going to go through and refactor and make the code a little bit cleaner. But for now, let's go ahead and create our position. Let's go ahead and add the player's size as well. So in order to make this work, we need to get the delta time. Now back down at the key callback, this is where we're actually going to listen out for the left arrow press and right arrow press. Okay, I just realized that we won't have access to the player position here. So just for the sake of time, let's go ahead and make that a global. Hey, there he is. He's moving left very slowly. But you get the gist. So we could do the same for the other. Obviously, we're going to give the player a velocity later on, but I just want you guys to see, this is the process. You can see it's a little choppy, but once we add the velocity with the delta time, it'll look a lot smoother. And then another thing is you can take the ship way out of bounds here, like on the left side. We could I'm pressing left and it's letting me go super far left. Same with the right. So a challenge for you guys is to try to make sure that it stays in bounds, so that we don't go further than the left side of the window and we don't go further than the right side of the window. See if you can figure out how to do that. Next, we're going to go ahead and refactor the code so not everything is in one main file. First, let's refactor the shaders. So include is where we're going to put all of our header files. Source is where we're going to put all of our C++ files. All right, and now we're gonna hash out the set integer and then the set matrix for util functions. Don't forget to add the class name in front of every method. All right, let's see if our shader class works. Okay, I'm not sure why this fixes this one error that we're having, but if I just move this code into the header file, it seems like that fixed that error. And then I was missing a semicolon down here. And now we're on to the next error. So this would be vertex source. This would be fragment source. Okay, because of time, I think I'll go ahead and stop here. We'll continue refactoring and continue with the game development in the next video. To recap, we installed all of the dependencies, we got our first window up and running, we got the main ship texture rendered, and we were able to add some movement to the ship, and then we were able to clean up the code a little bit and create our shader class. If you made it this far, thank you for following along, and I'll see you next time.